Lesson 8.3. So we'll start lesson 8.3 very similar to how we started the previous lesson 8.1. So we have two types of equations we're gonna use for this lesson. First we have z is equal to x plus yi. This is just the complex form. And then you have the z is equal to r cis theta. This is the polar form. Cis means cosine theta plus I sine theta. But for this lesson, we'll only use it as like this. You don't need to use it as this form at all. Okay, so let's take an example to convert from the complex form to the polar complex form. So first of all, we'll take an example. So 3 radical 2 minus 3 radical 2i. This is from question 18a on the book. So first of all, we'll find r, and then we'll find theta, and then we'll combine them. So the way you find r in this lesson is always positive, so it's always absolute value. So in the previous lesson, we would write plus minus radical, but in this lesson, it will only be plus. So plus radical, then x squared plus y squared. So here, it will be 3 radical 2 squared plus minus 3 radical 2 squared, which will equal 6. So this is our r. Okay, now on to finding theta. So the first step of finding theta is getting the quadrant. So here we can write this as a point 3 radical 2, negative 3 radical 2. So this is plus and minus. So let's draw a coordinate plane. Here in quadrant 1 it's plus plus, then here it's negative plus, then here it's negative negative, then here it's plus negative. So plus negative is quadrant 4. So now we can find theta. So theta is equal to tan inverse of y over x, which is equal to tan inverse of negative 3 radical 2 over 3 radical 2, which is tan inverse of 1, which is negative 45. Then we find theta prime, so shift tan on the calculator, negative 45. And then you take the positive value of the shift tan, so it will be 45. And now we do, so since it's quadrant 4, we have to find theta in quadrant 4. So the formula for theta in quadrant 4 is 360. This is in degrees. So 360 minus theta prime, which will equal to 360 minus 45, which will equal to 315 degrees. So it depends on whether they ask you to write it in degree or radian. So if they ask you to write it in degree, it will be 6 cis 315. If they ask you to write it in radian, you have to convert it to radian first. So 315 times pi over 180, which will give you 7 over 4 pi. So it will be 6 cis 7 over 4 pi. That's our two answers. It depends on which form they ask us in. This one is in degrees, and this one is in radian. Okay, so now we want to convert from the polar complex form to the complex form. This one's way easier since you can just do it on the calculator. So on the calculator, you have like a symbol. It looks like this. Depends if you have a scientific calculator. First, you'll have to set your calculator to complex form. So you do menu, and then press 2, and then you can find the symbol. You just search for it on your calculator, and then you do R, and then the symbol, and then theta. You can take this as like cis, for example. So we'll use the previous example we did. So 6 sys 314 or 315, 315. So we can just do 6, then the symbol, then 315, and we have to make sure our calculator is in degrees. So first we convert our calculator to degrees, then 6, then symbol, then 315. It gives us 3 radical 2 minus 3 radical 2i. Okay, so for our next part of the lesson, we have to know how to multiply and divide the complex numbers in the polar form. So we'll write the formulas first and then we'll solve an example. So we'll start with multiplication. So z1 times z2 is here we're assuming that okay, let me write the z1 and z2 first. Z1 is R1 cis theta 1, and Z2 is R2 cis theta 2. So Z1 times Z2 is equal to R1 times R2, then cis of theta 1 plus theta 2. So you multiply the r's and add the thetas. And then for the division part, so Z1 over Z2 is equal to R1 divided by R2 cis theta 1 minus theta 2 minus theta 2. So for the division part, the order matters. So if we do Z2 over Z1, it has to be R2 over R1 cis theta 2 minus theta 1. And if this product or this answer here gives us a negative answer, we'll have to add 360 to it so we can make it positive, because our range is always from 0 till 2 pi or 0 till 360. You cannot have negative theta here. Okay, let's take an example. So let's say z1 is equal to 5 radical 2 cis 225 degrees, and z2 is equal to 10 radical 2 cis 45 degrees. So we'll have to find the product and the quotient. So we'll multiply them and divide. So z1 times z2 is equal to r1 times r2 cis theta 1 plus theta 2. So z1 times z2 is equal to 5 radical 2 times 10 radical 2 cis 225 plus 45. Then on the calculator you do each one. So 5 radical 2 times 10 radical 2 gives you 100. Then cis 225 plus 45 gives you 270. Then you can either keep it this way or convert it to the x plus yi form depending on the answer choices. So if we want to convert it to the x plus y form, we can do 100, and then the symbol on the calculator, 270 degrees. We make sure our calculator is in degrees. So this will give us 100, then 270 will give us 100i. So this is an x plus y form. Okay, let's divide them. So z1 over z2 is r1 over r2, then cis theta 1 minus theta 2. So z1 over z2 is equal to 5 radical 2 over 10 radical 2 cis 225 minus 45, which will give us So it will give us 1 over 2 cis 180. Now you can either keep it this way or convert it to x plus y4. Okay, but let's say they give us z2 over z1. Okay, then we have to do 10 radical 2 over 5 radical 2 cis 45 minus 2 to 5. So here it will be 2 cis, then 45 minus 2 to 5 gives us negative 180. But we know that that's not in our range, so we have to add 360 to the negative 180. So it will become 180. Okay, so here they're asking for the same thing, z1 times z2 and z1 over z2, but this time we have it in complex form. So first we'll need to convert it to r cis theta, and then we're gonna multiply them and divide them. So let's do the first one first. So z1 equal to 24 plus 24 radical 3i. First of all, we need the r, so r is equal to plus 24 squared plus 24 radical 3 squared. So radical 24 squared plus 24 radical 3 squared gives us 48. And then to get the theta, we need to determine the quadrant first. X and y are both positive, so it's quadrant 1. So we do theta is equal to tan inverse of 24 over radical 24 radical 3 over 24. So this tan inverse of 24 radical 3 over 24 gives us 60. Then we find the theta prime, which will also give us 60, and then theta in quadrant 1 is equal to theta prime. So theta in quadrant 1 is equal to 60. So this one is 48 cis 60. Then on to the next one. So first we find r, it will be plus radical 4 radical 3 squared plus negative 4 squared. The calculator, 4 radical 3 squared plus negative 4 squared is 8, plus 8. Then theta, first we need to determine the quadrant. So it's 4 radical 3 and negative 4. So let's draw the coordinate plane. This is plus plus, this is minus plus, this is minus minus, this is plus minus. Here it's plus minus, so it's quadrant 4. So quadrant 4. Okay, now we can do tan inverse of y over x, so it's negative 4 over 4 radical 3. So tan inverse of negative 4 over 4 radical 3 gives us negative 30. We do theta prime, shift tan gives us 30. Then in quadrant 4, theta prime is equal to, or theta in quadrant 4 is equal to 360 minus theta prime, which will give us 330 degrees. So here it will be 8 cis 330. Okay, now we multiply them and divide them. So back to our formulas, the formulas we have here. So we have z1 times z2 is r1 times r2, and then we add the thetas. So z1 times z2 is equal to r1, which is 48, times r2, which is 8. Then cis 60 plus 330. And the calculator, 48 times 8 is 384, cis 390. Now 390 is out of our 0 to 360 range, so we subtract it by 360. So 390 minus 360 gives us 30. So this will be 30. Now we can either keep it this way or convert it to rectangular form on the calculator, which will be 384 and then the symbol 30. Make sure your calculator is in degree. 384, symbol 30. Gives us 332.5 plus 192i. Then for z1 over z2, you do 48 over 8 says 60 minus 330. So 48 divided by 8 gives you 6. Then sys 60 minus 330, which is negative 270. Now we have to add 360 because we cannot keep it in negative, which will give us 90. Now let's convert it to rectangular form. So 6 and the symbol, then 90 is 6i. So you can either write 6i or 0 plus 6i. Okay, let's move on to the next idea in our lesson. So when we have, for example, z to the power of 100. So let's take an example here. We'll do 2 plus 2i to the power of 100. So first of all, we cannot keep it in complex form. We have to convert it to the polar complex form. So if we do it, I just won't do it. I already have it done. It will become 2 radical 2 says 45. So this will be power 100. So what you would do here is you'd make this power 100 and you'd multiply this by 100. So again, you're gonna make this power 100 and multiply this by 100. So it will become 2 radical 2 power 100. So z100 is equal 2 radical 2 power 100 says 45 times 100. So we can just do it on a calculator. 2 radical 2 power 100. It will give you like 1.421045. Then sys 4500. In the quiz, they'll give you like more simple numbers to work with. So for the last idea of the lesson, they'll ask you to find a number of roots. So we'll take an example here. So find the 3 roots of 64 sys 180. This is just an example. So here you'll need to use another formula, which is radical Rn sys then theta plus 2 pi k over n, or in degree form it will be radical Rn sys theta plus 360k over n. So n is the number of roots, and you can think of k as like a rotation. So k will always start from 0 and then go to n minus 1. So if we have like 4 roots, our first root has a k of 0, this first root. Our second root has a k of 1, our third has a k of 2, and our fourth has a k of 3. So it goes from 0 till n minus 1. Here n is 4 and k is 3, like the maximum k is 3. Okay, but this is not our example, so we don't need it. Okay, so back to our example. So here it will go from k equals 0 until since we have 3 roots, it's n minus 1, so it's 3 minus 1. So it's from 0 till 2. On the test, since it's multiple choice, they'll just show you the answers and they'll ask you if it's it. And they won't ever bring like big numbers of k. I don't think it would exceed 5, for example. Okay, so back to the formula. So that we did k, we did n. R is just the R here in R sys theta, and n is the number of roots. Okay, now we can do the formula. So we'll do the formula for each k. So for k equals 0, which is the first root, we have 3 roots, so it will be from k equals 0, for k equal 1, for k equal 2. So for k equals 0, it's r is 64, then n is 3, then sys theta is this here, so it's 180 plus 2 pi. Well, we'll use the degree version since this is already in degrees, so it's 360, and then times k. K is 0 over, and n is 3, so it will be 8 sys 180 over 3, so it's 8 sys 60, and you can write it in rectangular form using the calculator. So next one, it's radical 64 of 3, then sys 180 plus 360 times 1 over 3, so it will be 8 sys 180 plus 360 over 3, which will give you 180. And then the last one, radical 64 of 3, sys of 180 plus 360 times 2 over 3 equal to 8 sys, then on the calculator it will become 300. And those are our 3 answers. On the quiz or on the final, they'll give you like 3 and 1 incorrect one, and you'll have to find the incorrect one. A few final notes for the lesson. If they ask you for the argument, they just mean they're asking for theta. If they ask you for the modulus, they're asking for r, or absolute value of z. And one last thing, they might give you like complex form, for example, like 5 plus I, and ask you to graph it on the complex plane. So the complex plane, this is the real, this is the imaginary. It's the same as x and y. So this is 5 plus 1i, so you can write it as 5 and 1 as coordinates, and then you'd plot it just like you'd plot normally in a coordinate plane. So 5 on the x, 1, 2, 3, 4, 5, and then 1 on the y, and you draw a ray. Okay, let's do another one. So z equals 3i, so this is the same as 0 plus 3i. Then on the coordinate plane it's 0 and 3, so in the imaginary plane, so x is 0, then y is 1, 2, 3, and you draw a ray upwards.